Next, we have a talk from Edward and Stephen from the University of Washington. The talk is called Peer-to-Peer Syncing and Live Editing of Shared Virtual 3D Spaces, Challenges and Opportunities.
Great. So I'm here to present a paper on peer-to-peer syncing and live editing of shared virtual 3D spaces. And I'll talk a little bit about some of the challenges that we faced in implementing these spaces and some opportunities that we see for the spaces. So I wanted to begin with an observation. When we look at an image like this, we are sort of reminded of a somewhat different view of what computing might be. So in the present day, when we think about how computing occurs, it generally occurs across screens that are sort of restricted in the way that they can represent information to us, and restricted in the way that we can share the sort of information being interacted with. And while it is possible, increasingly possible, to sort of share what we are seeing on screens, as we kind of have here, it's still much less natural than what we see occurring in this image, where you have sort of two users playing with the same set of objects. And I just want to explain this image, I guess. So what's going on here is this is the logo turtle. This is a physical, if you've heard of like turtle graphics, this is like a physical robot, which is being controlled by a limited subset of the logo programming language, which is tied to the buttons on this machine. And that's being used to draw out an image on the floor here. And you can kind of see both of these users are able to interact with and refer to the parts of this system quite easily. Yeah, so I guess the lesson here is that spaces and objects are very easy to think about and share with other people. It really builds a different kind of like computing style. However, the other sort of observation here is that if we look at how big these are with respect to the users, these objects are a little bit inconvenient, right? If these users want to move this turtle around, it's as big as their own body, and so it's a little bit inconvenient to have to set up a space every time you want to use it. And of course, since our talk is about virtual spaces, you're going to say, well, yes, maybe the idea here is to just use VR. But there are problems with using VR to solve these issues. And the first kind of issue is that most programming uses text, and VR is just not very good for text input. And while there are definitely ways of sort of turning programs into sort of virtual representations, there's a lot that I think might be missed out on something that does not include text. The second issue is that headsets are expensive. Even though a headset might, in the modern day, a headset might run you less than creating these dedicated devices for many different applications, it's still a little bit expensive. And so our idea to a solution here is to begin by enabling cross-platform collaboration. So there's kind of so I want to explain what's going on here. So on the left side here, we have the view of a system from outside of VR, where one user is working inside of VR and the other user is sort of observing what is going on a computer, and might be able to interact with the system through the computer. And then inside of VR, the user is working and can see all these virtual objects, including maybe a virtual console, which allows operation of the virtual objects. So I want to sort of present some videos from our system to show our ideas of how a system like this might work. So I guess I'll just start this video. So the first thing that you can see down here is this is a browser that is running an observable notebook, which has these cells that run code. And here what you'll see is that this is a while loop, which is going to send messages to this object here, which is running in Unity at a rate of 60 Hertz. So right here, it's going to make the object bounce around within a particular delta. So it's just bouncing around, it's sort of taking random positions. And what you can kind of see there, it's a little bit quick, is that we're able from this notebook to start and stop the motion of this object. Similarly, we're able to tie, using a reactive notebook like this, we're able to tie inputs like mouse input to behaviors in the space. And this occurs pretty smoothly. So this defines an array of 100 objects that are updated with the motion of the mouse as it moves over the red box. And using this, we're able to interact with the physics of the space. So then we have a sort of full demo of this system that we've created here, involving a headset and a notebook and a Unity peer. So all of these are running sort of separate clients that are connected to this, that are managing the representation of this space. So the interesting thing is that all of these separate clients have an idea of what the space looks like. They all know there are some blocks in it. But at the same time, some of them have to control what is going on with those blocks. So in this simulation, you'll see that the headset, is it gonna, sometimes Google does this. Yeah, it is going to want to, let's try that one more time. Hopefully, can you all still see?
Yeah, we can see that.
Great. Okay. So here I'm creating some blocks using a tool I built. You can see, so what's occurring here is that I'm moving around the blocks, and that those physics are being sort of calculated on the headset, and all of the updates in the object positions are being sent to both the Unity peer and the browser peer. And so there's really no physics occurring on either the Unity peer or the browser peer, but you can see those sorts of representations are visible in both of those places. And this was a test of the system's support for a large number of objects, because what's going on here, a large number of objects and a large number of updates. Because what's going on here, right, is that all of these, what you're seeing here is lots and lots of updates as the objects sort of bounce against each other and each transmit, position and rotation and so forth, updates of those positions. So the idea is that the system is pretty robust to these updates. The algorithm that we use is pretty naive, and as we get to like around, this is like 96 objects, it begins to have some trouble because there are a couple of peers that it's having to send all of these updates to. But the remarkable thing is that if we look at the latency between our system and what is occurring here, it's going to be within a single frame. Because we are using WebRTC, which is a sort of peer-to-peer connection that it doesn't have to go through a server elsewhere. So our system has some limitations, and we have some lessons that we've learned. The first limitation that was very clear as we were working was that WebRTC was not trivial to set up. And it's not trivial to sort of add new types of platforms to a WebRTC system. You have to sort of set up a kind of handshake for each system, and that's unfortunate. The next kind of limitation we identified was that VR development is still very far from a live experience. There's lots of compiling applications and swapping between, having the headset on and taking it off. One thing that we really liked was that using observable was an easy way to get a decent live programming interface without too much work. It was really great to be able to sort of instantiate different clients and without really thinking about that process at all. You can spin up, several clients and change what different clients are sending on the fly. Our system is not really the first to consider some of these design issues. So there's a great paper by Cao et al. At MIT on programming inside of VR. They detail several systems that try to solve the problem of how do you build a programming language for VR. Then there's also Transceiver, which is a really cool paper on solving the problem of how do you talk between an external human operator to an internal human operator, outside of inside of VR. So as a final takeaway here, I wanted to sort of point to this idea that VR promises to become an important part of the future of computing, and VR user interfaces are still in flux, which makes this kind of a critical moment. So I think we should push to make programming in VR something that everyone can do and a standard part of many types of interfaces. So yeah, thank you. I want to thank my advisor for helping me with this project.
Thanks, Edward. We have time for questions. Question from Jess.
Hey, Edward. Super cool interface. I love the multi-clients, like single model way of doing things, and it's fun to think how you could extend that arbitrarily to other client views into that same interface or data. I was curious how you mentioned like observable, but I'm curious how you did replicated state across your 3 clients. And you also mentioned that like once you kind of got to like 90 objects in the scene, you even started experiencing some latency, even within like the peer-to-peer local network that you were running with WebRTC. Yeah.
So the way that we used a very sort of simple model where the different clients have their own states. This lets you kind of operate them independently. So you can start up one. It doesn't really matter which one you start first. And you can also sort of start up the browser, start up the headset, make some changes to the space, and then turn off the headset, and the browser will kind of store that state. But that distributed state also leads to some problems in terms of if you are sending updates all around, you have to make sure to keep everything in sync. And we don't have a great solution for that. We are basically just sending lots of very fast updates, and that generally keeps things in sync. Right. Sometimes we'll send something to update the entire state to make sure that things remain roughly in sync, but we definitely do not have a robust solution to that problem yet.
Gotcha. Cool.
I had a question around like the notebook interface. I was wondering like what kinds of people would find being able to program in a notebook useful for working with VR?
Yeah, so I think it's I think the main benefits of working in a notebook right now were for us during development in terms of the sort of excellent reactive nature of like in order to sort of visualize different aspects of the space very flexibly. It's very easy to sort of write little visualizations in a notebook. So I think it serves well as a dashboard. But in terms of providing a user, like an end user interface, I think there's definitely more effort that needs to go into developing it so that a standard end user is going to be able to use that interface. But I do think that the notebook sort of model works pretty well for kind of the document model works well for allowing users to sort of build their own applications rather than tying or locking them into a single sort of structure.
Got it. Brian, we have a question from the audience.
Actually, it's a question from me.
Oh, okay.
So you have this ability from different devices. One person might be on a computer, one person might be in VR. Have you tried this? Like, tried to do this kind of programming with another person, or is it always just you switching back and forth between your headset and your computer? What is it like?
Yeah, so I actually did with some during during the pandemic, I with a couple of friends who live across the country, I had them like run the programming interface, and then I was in VR and they were able to sort of move things around, and that was pretty cool to experience. That like having someone sort of write code that like generated new stuff in front of you, but I think there's definitely a lot more work to be done in terms of right now the two interfaces are pretty they serve pretty separate functions. Like the programming interface does all the programming and the virtual interface does all the sort of object manipulation. And I think there are ways of changing the capabilities of those two interfaces to allow them to interact more, to work on the same types of problems to some extent.
So you said they were your friends. Did they figure out how to troll you?
I think, yeah. I mean, if you send enough objects to the system, it'll break things. But then you can also just create sort of explosions of objects. So yeah, there some fun, some trolling was done.
All right, thanks.
Yes, question from Jens.
Yes. Do you have an idea if it makes sense to represent the notebook or the behavior in the 3D world, or is it just use the very specific parts only with the visualization in the 3D world?
That's a great question. I think that's one thing that we have thought of as a very straightforward way of adding that programming capability to VR, to the sort of virtual world, would be to just create do that, to create a representation of the notebook in the virtual world, even just sort of displaying a screen that has the notebook available there. But that still suffers from the sort of text input problems that I mentioned in the presentation. So I think there are ways that it could be done, but it would require some careful thought around the user interface. And as things are right now, there are going to be limitations on what you can, what a user in VR is going to be able to program.
Thank you.
Okay, thanks again, Edward. That was great.